A fiery streak from a distant star, or just a trick of the light? On October 7, 2025, the European Space Agency drops its first image of an interstellar comet and, well, the world just ignites with controversy. While official channels offer blurry photos and technical excuses, NASA and other global agencies go completely silent. Amateur astronomers, however, start releasing sharper images from their own backyards, fueling speculation and outrage. What are we not being told? Let's explore this together. The blurry dot. It was meant to be a historic reveal, but it ended up a global meme. At precisely 9:22 UTC on October 7, 2025, the European Space Agency's ExoMars Trace Gas Orbiter released its first official images of the interstellar Comet 3, I/Atlas. The public, primed for a stunning portrait of a visitor from another star system, received something vastly different: a faint, blurry dot, barely visible against the digital noise of deep space. The image, captured by the orbiter's color and stereo surface imaging system, or CASIS, was immediately distributed across social media. But anticipation quickly soured into confusion and disappointment. Within a few hours, hashtags like fuzzy dot and where are the pics were trending in multiple languages. This wasn't just a low-quality picture, it felt like an anticlimax to a highly anticipated celestial event. The world tuned in for a cosmic marvel, and was shown a smudge. For many, this raised immediate questions. As Dr. Frank Marcus, a senior planetary astronomer at the SETI Institute, noted, the public has grown to expect crystal-clear imagery from our space missions, making the blurry photo feel like a deliberate withholding of the real view.
Global outrage.
That blurry dot didn't just disappoint, it sparked a wave of digital fury. The initial letdown quickly escalated into genuine outrage as armchair analysts and amateur astronomers launched their own inquiries. Social media platforms were flooded with side-by-side comparisons, pitting the fuzzy official image against captures from backyard telescopes that appeared to show significantly more detail. The comment sections on agency posts turned into forums for accusations, with many users convinced that ESA was hiding something profound. This anger was magnified by the coordinated silence from other spacefaring nations. NASA, China's National Space Administration, and the UAE Space Agency, all operating orbiters around Mars, released nothing. No images, no press releases, no confirmations of their own observations. This collective silence felt deeply suspicious. People began to question why three independent, highly advanced space programs would all fail to get a clear shot. As astrophysicist Dr. Jesse Christensen of the NASA Exoplanet Science Institute often explains, maintaining public trust is paramount in science, and transparency is key. Every unanswered question only intensified the pressure, transforming a scientific observation into a full-blown public relations crisis.
Technical limits.
Was this a grand conspiracy or simply the hard limits of physics? Let me explain what was happening on the ExoMars orbiter. The CASIS camera was never intended to be an interstellar comet tracker. Its primary mission is to create detailed color maps of the Martian surface, identifying geological features like landslides and seasonal frost changes. Aiming it at a dim object 30 million kilometers away stretched its capabilities to the absolute maximum. Nicholas Thomas, the camera's principal investigator from the University of Bern, described the effort as a very challenging observation, emphasizing that the comet was at least 10,000 times fainter than the Martian landscapes CASIS was built to photograph. At that vast distance, a single pixel from the CASIS sensor covers a massive 340 square kilometers. The comet's nucleus, thought to be only a few dozen kilometers across, was far too small to be resolved. It was, in technical terms, a sub-pixel target. No amount of perfect focus or long exposure could turn it into anything more than a smear of light on the sensor. The resulting fuzzy dot wasn't a cover-up, it was the unyielding reality of the hardware's design.
HiRISE goes dark.
Just as the world needed its most powerful eye on Mars, the camera went dark. NASA's Mars Reconnaissance Orbiter is equipped with the High-Resolution Imaging Science Experiment, better known as HiRISE. This is a formidable telescopic camera, capable of spotting rovers, and even their tire tracks on the Martian surface from orbit. It represented the best chance for humanity to get a clear, detailed image of 3I Atlas's core. But as the comet made its closest pass by Mars, HiRISE was effectively out of commission. The reason was a US government shutdown that began on October 1, 2025, which froze the majority of NASA's day-to-day operations. All non-essential activities, including the uplinking of new commands to spacecraft and the public release of data, came to a halt. Astronomers, including the HiRISE camera's principal investigator Dr. Alfred McEwen, could only watch the empty public archives, waiting for data that would never appear. The shutdown severed the command chain, freezing the entire data pipeline. HiRISE's forced inaction created a crucial information vacuum, leaving the narrative to be shaped by blurry images and a growing cloud of suspicion.
Radio silence.
The silence wasn't just a NASA problem, it was a global phenomenon. With the HiRISE camera offline, attention shifted to the other advanced orbiters circling Mars. China's Tianwen-1 and the United Arab Emirates' HOPE mission had both been tracking the comet's approach for weeks. These missions are equipped with sophisticated imaging instruments and represent the expanding international presence at the Red Planet. Yet, during the critical flyby window, both the China National Space Administration and the UAE Space Agency remained completely quiet. Not a single image was released, no official statements were made, not even a simple denial of an observation attempt. This radio silence from two other continents was perplexing. The US shutdown explained NASA's situation, but it didn't account for the lack of information from China and the UAE. As Dr. Brian Whedon, a space policy expert at the Secure World Foundation, has noted, international data-sharing agreements can be complex and are not always immediate. In the absence of any official word, speculation filled the void, deepening the mystery and fueling theories of a coordinated cover-up.
The image wars.
While the professional agencies remained silent, the amateur astronomy community took center stage, and the internet became a battleground of images. In the days after ESA's underwhelming release, a torrent of pictures from backyard astronomers around the world began to circulate online. Using advanced techniques like stacking dozens of long exposure frames and applying AI-powered upscaling filters, these dedicated hobbyists produced images that seemed to reveal stunning details. One group, championed by popular online comet hunters, claimed to see a sharp nucleus and even faint jets of gas, arguing that their ground-based setups had outperformed billion-dollar orbital missions. However, professional astronomers, including Dr. Quanji Ye from the University of Maryland, urged extreme caution. They countered by showing how aggressive digital processing can create convincing illusions. They explained that astronomical techniques like deconvolution, when pushed too far, can easily amplify background noise, turning random digital artifacts into what look like real structures. The debate quickly became highly technical, but the fundamental issue, as the professionals pointed out, was the inescapable limit of optical resolution.
Perseverance streak.
So, could a rover on the ground succeed where the orbiters had, well, failed? On October 7, 2025, a skeleton crew at NASA's Jet Propulsion Laboratory decided to find out. Despite the government shutdown, essential mission personnel were still on duty. And they authorized a special observation sequence for the Perseverance rover. They commanded its navigation camera, or NavCam, to take a series of exposures of the sky over Jezero crater, hoping to catch a trace of 3I Atlas. Now, the raw images revealed a single faint streak of light just over a pixel in width, stretching diagonally across the frame. Its timing and position were a perfect match for the comet's predicted path. The science team, including veteran imaging specialists like Dr. Justin Mackey, began to analyze the physics. The streak's length was consistent with the motion blur expected from an object moving at the comet's staggering speed of 90 kilometers per second. It was an electrifying piece of evidence from the Martian surface. But, a critical piece of information was missing. The full FITS data headers, which contain the precise exposure timing. Locked away due to the shutdown, this missing detail meant the observation remained a tantalizing but unconfirmed clue.
Wow signal link.
Just when the story seemed like it couldn't get any more bizarre, it intersected with one of the greatest mysteries in the history of astronomy. As scientists plotted the precise trajectory of 3I Atlas, they uncovered a jaw-dropping coincidence. A line drawn from Perseverance rover's location in Jezero crater through the comet on October 7th pointed almost directly to a region of the sky in the constellation Sagittarius. This patch of sky is famous for being the origin point of the WOW signal. Back in 1977, astronomer Jerry Amon detected an incredibly powerful 72-second radio burst from this exact direction, a signal that has never been explained or heard again. The comet's alignment with this historic anomaly was just too perfect for the internet to ignore. Yet, despite the incredible coincidence, no major radio observatory, including the SETI Institute's Allen Telescope Array, under the guidance of senior astronomer Dr. Seth Shostak, announced a dedicated listening campaign on the 1420 MHz frequency of the original signal. The optical silence was now compounded by a profound radio silence, raising an unsettling question. With the geometry perfectly aligned, why did no one seem to be listening?
Approaching perihelion.
Every comet that ventures into the inner solar system must face a trial by fire. On October 29, 2025, 3I Atlas will reach perihelion, its closest point to the Sun. As it swings around our star, it will disappear from our view, lost in the Sun's intense glare. For nearly 48 hours, no Earth-based telescope will be able to safely track it. This impending observational blackout is becoming a fertile ground for speculation. Cometary experts like Dr. Casey Liss of Johns Hopkins University's Applied Physics Laboratory note that this will be a period of extreme stress, where comets can violently disintegrate or experience massive outbursts. But others are wondering if the blackout could be hiding something engineered, a deliberate course correction. The Galileo Project, a Harvard-based team led by Dr. Avi Loeb dedicated to searching for signs of extraterrestrial technology, has announced it will be monitoring all available channels for any anomalies as the object re-emerges. The world can only wait and wonder. When 3I Atlas comes back into view, its brightness, trajectory, and physical state will provide the next crucial set of clues to its true nature.
The November tests.
As 3I Atlas rounds the Sun and is expected to re-emerge into view in early November 2025, a global campaign of intense scientific scrutiny is set to kick off. Astronomers will then focus on a critical checklist of tests to determine what might have happened during its solar passage. First, they will meticulously analyze its light curve, the graph of its brightness over time, searching for any sudden surges or steep drop-offs that would signal it has broken apart. Second, they will use the new data to run hyper-precise orbital models, looking for any tiny, unexplained deviations from its predicted path. Such a change could be evidence of natural outgassing jets, or as some are still theorizing, something far stranger. Hopes for an even better look are resting with ESA's Jupiter Icy Moons Explorer spacecraft, known as JUICE. Though it is on its long journey to Jupiter, it has a unique vantage point and a scheduled observation window. However, as confirmed by JUICE project scientist Dr. Olivier Vitas, the vast distance means that any data it collects won't reach Earth until deep into 2026. Until then, every new measurement from Earth will be another clue in a puzzle that has captivated the world. So, what are we to make of the interstellar comet 3I Atlas? The story began with a single blurry dot and exploded into a global mystery, a perfect storm of technical limitations, inconvenient political timing, and humanity's profound hope of finding something truly extraordinary in the cosmos. While the official narrative points to the hard limits of our technology, the deafening silence from multiple space agencies, combined with tantalizing clues from the Martian surface and a spooky alignment with an old cosmic mystery, has left the door wide open for speculation. As we continue to wait for more data, the saga of 3I Atlas stands as a powerful testament to how much we have yet to learn about our universe, and how quickly a single unexplained event can ignite the imagination of the entire planet. Don't forget to like, subscribe, and hit the bell icon. Thanks for watching Future Facts.